Hello, you absolute legends. The oxidation of alcohols, the resulting product of this reaction. Now, I have oxidation here in square brackets because if you look at some textbooks, it'll just have a letter O for oxygen with square brackets to tell the reader that we're talking about the oxidation reaction here. Now, there's certain reagents that are oxidizers, such as PCC, potassium chromate. I'm not talking about specific mechanisms, I'm talking about any and all of those that do oxidation reactions here. Now, with respect to alcohols, the first thing you have to identify is that are you working with a primary, a secondary, or a tertiary alcohol? Then the second thing I would identify, are we talking about oxidation or reduction? So with oxidation, let's start with a primary alcohol. So a primary alcohol is identified because the alcohol functional group is attached to just one carbon. So this carbon here is the one I'm looking at, and it is attached to one other carbon. So I want to identify this as a primary alcohol. Now, oxidation reactions, in short, they create carbon-oxygen bonds. They create carbon-oxygen bonds, and they, in the same breath, they also destroy carbon-hydrogen bonds. Now, one thing I want to make very clear is that the oxidations are not going to destroy carbon-carbon bonds. They are not going to break that bond. That bond is going to stay intact. So with the oxidation of a primary alcohol, let's keep our carbons together. We have our 3 carbons. Now, when I'm trying to predict the product of a reaction in basic OChem, I just redraw my starting materials because my final product is not going to be terribly different. This way I make sure that like all the carbons are transferred and everybody's carried over there. So oxidation of alcohols, this is a primary alcohol. It is going to create a carbon-oxygen bond. So I'm going to draw that bond in there, and then I'm going to think to myself, if a bond is made, bonds had to be broken. And I'm going to think to myself about the general patterns that carbon and oxygen tend to bind. Carbon generally binds 4 times. Right here in this stick picture, carbon has 1, 2, 3, and then a 4th bond, a hydrogen, that was there the whole time. We're just now drawing it. So this carbon has its 4 bonds. This oxygen here has 1 too many bonds. We're going to get rid of this hydrogen here. So we created a carbon-oxygen bond, and then making sure that no carbon-carbon bonds got broken. Carbon's bonded 4 times, oxygen's bonded twice. Here are some models trying to show the primary alcohol starting material and that primary alcohol final product. Where we got the 3 carbons. It's a primary alcohol because looking at this carbon, it's bound to one other carbon. And here's our product here showing the aldehyde. What if it is a secondary carbon? A secondary alcohol, excuse me. So looking at chemical reactions, we want to make sure what's going on here. Here we have a secondary alcohol. And here's a little model kit trying to show that secondary alcohol. Now it's secondary because looking at that carbon that the alcohol is bonded to, this carbon is bonded to 2 other carbons. So we call it a secondary alcohol. It's going to go through oxidation. So to predict my product, I'm going to redraw the starting material. So that way I make sure I have all my carbons and everything hooked up. Oxidation creates carbon-oxygen bonds, and then I go in and count it up. This carbon is bonded 4 times, nice. This oxygen up here is bonded 3 times. I'm going to erase one of these hydrogens here. So sticking with that pattern of creating a carbon-oxygen bond and then accounting for some of the common patterns that atoms seem to bond. We're getting some quick answers here. And this is a model kit showing that secondary alcohol forming what's called a ketone. Now there's a third type of alcohol that we classify called a tertiary alcohol. And here is a model kit of a tertiary alcohol. Where we have 4 carbons present total. Again, looking at this carbon in the center here, looking at this carbon that the alcohol functional group is bonded to, this carbon is bonded to 3 other carbons. That's why we're calling it a tertiary alcohol. Now, in oxidation, we're going to create carbon-oxygen bonds, but carbon-carbon bonds are not going to break. We haven't broken any carbon-carbon bonds along the way here. Let's kind of run through this here. Start from the beginning. We'll just redraw everything exactly. Now, if we create a carbon-oxygen bond, like we've done all before, and then we look at some of our patterns of bonding, this carbon here is bonded 5 times. This is going to be a no-go. We are not going to break carbon-carbon bonds. In general, in OChem, I would not break a carbon-carbon bond unless we're talking about a reaction class that is going to do that, because carbon-carbon bonds are very strong. This is how to predict the products of the oxidation of primary, secondary, and tertiary alcohols. Thank you.